So problem 2 for today. The second problem I tried to do in class on Friday. So we see that now we have a building and now we know the velocity that it leaves the roof. And actually I can see where I should have done this one first, but it's neither here nor there. So I'd ask what is the speed just before it hits the street. And let's see, do we know? Yeah, 30-meter tall building. I labeled it. I put a label for the V sub 0y. And then once again, we're going to say the top of the building is at y equals 30. The ground at 0. I've written down what I know. And we could add into this that well, we know, let's see, that the speed at the top, yeah, I wrote that. That's something I can infer right away. The v at the peak is equal to 0. And we could, in fact, add in a marker for that. One thing is that I noticed that it doesn't actually, we don't know this. We know that v at peak equals 0 meters per second. And whenever you write out, just look and see it's 3 sig figs, 3 sig figs. So even if it's 0, I do that. So it doesn't ask me about time, doesn't ask me about how high it is. So it's a pretty dead ringer for this one, equation 2.13. And so I identify that, I want the speed at the ground. And so V0 is going to be V peak. I only could add that now. So this is going to be V peak. That's why one of the reasons draw out the picture, because if it's a two-step problem, you need to identify what to substitute in each time. Of course, this is very badly written. It's the acceleration of gravity. That's always the same. And the starting point is the top of the building. And so ground would be the plane y. So then I've got the equation. And I suppose I could have actually, if I wanted to be very strict, I could see how I have letters here and here, but I put numbers, so a little sloppy, but at least I have the equation here. And, I'm thinking in terms of how to max points on an exam. And then we just go down the line. Notice once again, we're going to end, this is going to become positive. So there's no chance, it would be tough if we got a negative number. If you do get a negative number, at least at the end, then you got to be a little suspicious. I take the square root, and I'm using scientific notation now. And so we just have to remember now that with the when we're using these squared equations, we lose information about the direction from the equations, so we have to put it in ourselves. So I already designated this as the positive direction, so that's negative. So it's, if you put both, it's a little overkill, but it works, right? It's very unambiguous. And let's see what's next. So now it wants to know how much time. So I look at this. And this is where doing problems helps, because I realized that it never asked me for the height of the peak. So even though I know it, they gave me the building and I know the ground is 0, so it might make you think that I should use the peak, and it would be consistent with what I did before. But in that case, I didn't know the initial velocity. So if you knew that, when you know this initial velocity, it's really a lot easier of a problem to do. So then what I said is, okay, I'm going to concentrate on equation 2.8 because I know some things. So I know that going up to the peak, the velocity at the peak is going to be equal to 0. So then when I do my algebra, I don't even have to bother. I made that go to 0 first because I was a little lazy. Sure, I could have put the V peak into it. Let's see, that would have been then blah blah blah. Yeah, V peak minus V sub 0, and then made it go to 0 and have it disappear. And then I do my algebra. Yeah, that's why I did that, because it just made the algebra a little easier. And then I end up with this simple equation here. And notice once again, it comes out positive. That's really great. 2.24 seconds to go from the top of the building, and it's going upwards to its peak, where it turns around and starts falling. And so building to peak, peak to building, because we need to know what's the total time. So at first I was going to double these and then go from here down, but it isn't even necessary. I mean, of course, remember on the return trip, when it's going back past this point, it's going to be going at negative 22.0 meters per second. But I realized that I know how long it took to get to the top, and so I can just use the same equation again because V peak is equal to 0. But now I want to get the V ground. And notice that here, let's see, V peak is here, that in this one. And no, you see now V peak is inside, so that makes it slightly different. And we had this V ground minus VP, and we get the two minus signs. So now remember, it's going into the ground, so the direction is negative. So once again, we end up with a positive number, so that makes us really happy. If we started getting negative seconds, we'd be unhappy, and we'd want to double check. So then we know it's going to take 2.24 seconds to get here, and then from here, 3.34. Now, mastering, the book says reflect. So remember, in the last problem, and even if we look at this without looking at the other problem, 22.0 meters per second is pretty fast. I mean, I think you need to be a major league pitcher to actually do that. And notice that it's going at negative 32.7 meters per second from here. So from here to here is 22.0 meters per second. And so what's adding it on another 10 meters per second. But this is, T peak is considerably higher than the 30 meters, very similar to the bridge. But anyways, the point is that it takes us 2.24 to come up, 2.24 to go down. So that left us with 1.1 second. Yeah. So in 1.1 second, just to show you a double check, so delta V is going to equal the 1.1 seconds times the acceleration, which we'll just say for the sake of argument is 10 meters per second squared. So that's 11 meters per second. Delta V equals delta V while it's going from the top of the building to the bottom is 11 meters per second, and of course it is negative. So you see right off, there it is. So That all happens in that short distance, so it's all consistent. And then when I got to 32.7, I was a little skeptical at first because I had forgotten from the problem before that I'd done that it's going to go awfully high. And so I used the two equations, and you see at 2.24, well, it actually doesn't go. I'm surprised it didn't go as high as the bridge and the rock, but it went up another 20 meters. Interesting. And then you see the V gets to 0 right here, and then it starts coming back down, and it crosses here at the top of the building at 30 meters. Once again, it's going negative 22, and then it builds all the way up to its speed that it gets just before it hits the ground. And I tried to figure out exactly what it was, but for us, the 5.58 seconds is fine. Okay.